that's a large-scale mock-up of what the actual first point contact transistor looked like. This little right up here was put out by Brian Goodman in the October 1948 QST. I'll let you read it. And he's basically saying, it ain't going to be right away, guys, but it could be pretty interesting before we're done. And of course, as we know now, he was pretty much dead on. So one of the first examples of ham radio in a transistor transmitter actually was in 1953 QST. It was the cover story. And this is the picture of the one transistor transmitter he made that put out an estimated 50 microwatts. And George Rose, K2AH, worked in the research labs at RCA, and he designed and built this transmitter and used it for a CW contact with his friend W2UK, who was 25 miles away. A second in-depth article on this transmitter was in the March 53 issue on page 13. This item today currently resides in a museum where we proudly display it. It's quite a piece of engineering, and of course, when you've got research labs behind you, it's amazing what you can put together. Even though here the transistor was already 5 years old, but this was at 144 megahertz. Keeping in mind that the idea behind the transistor was to develop an audio device that would replace the tubes in long distance telephone lines. So the fact that he got this to work up at 144 megahertz was pretty phenomenal. So things went on. Here was a big chance in the 1953, Raytheon released the CK721 and 722 transistors. The news they didn't release at that time is that when these were 761s and 762s, that failed the final test required of the hearing aid transistors they were trying to build. So rather than throwing them away, they rebranded them down to CK722s and sold them to whoever wanted to buy them and play with them. And it worked out pretty well. A lot of people jumped on the bandwagon. And then they offered, as icing on the cake, this ad on the right where it says Raytheon's Transistor Application Contest. And it was going to be big money. And as far as I could determine, I never saw any mention of this contest ever again anywhere. So I don't know what happened out of it. Later that year, in the September issue, was a modulated CW adapter to plug into your AM transmitter. This transistor is described only as a point contact type with no information as to where one might purchase it. In December of '63, very basic general theory of transistors was published in QST. But not until 1954 did we see a real breakthrough here when the Regency TR1 receiver was released to the public for $49.95. And it ran a pretty long time on a 22.5 volt photo flash battery. And we have a working example of this radio in the museum, and it was repaired by Pete Shuk, one of our volunteers. It actually functions. Finding the 22.5 volt batteries is not simple, however. Finally, in February of '56, Allied Radio advertised a transistorized code practice oscillator, and that was only $4.95. So there's something that's really a first working piece of equipment for the amateurs. Not sure the modulated CW audio thing was for the hams. I don't think it caught on much. So going back to the old days, QST in March of 1958 published a 7 megacycle MOPA using the CK761 and 762 transistors. Obviously, they were spending the big bucks on the good transistors. Also in March 1956, Lafayette advertised the CK722 for $1 and the GE 2N107 for $1.25. And there was a code practice oscillator for $2.99 with a single earphone for $1.13. So a little bit of everything is beginning to show up there. May 58 brings us to an article on an all-transistor experimental superhet. No real construction details or part sources were given, and it's interesting to note that very few miniature parts were available to this hobbyist yet. But most of these projects were built with items from tube circuitry. Now we have a practical transistor code practice set. Note that the transformer is is a universal output transformer for a 4-watt tube circuit. Not much danger of losing that component to misuse. So this was a square wave generator later to turn into power supplies and that kind of thing. We find we have a few hobbyists publishing articles on small projects. There seem to be quite a few crystal calibrators, code practice oscillators, and low power audio circuits. The frequency limitations of the cheap transistors are keeping us constrained. So in May of 1956, an article on limitations was published. And in June, a list of readily available transistors, 8 in total, was included in a general description of transistors and who was making them. In August of 1956, Regency dropped another bombshell. This was the ATC-1. It was a fully transistorized ham band converter for your AM car radio. All you had to do was unplug the car radio antenna from the car, plug it in the back of this, and then they supplied you a jumper cable to come out of this and go into the car radio. That was the entire install. So it was a 2-transistor circuit, and it worked on 80, 40, 20, 15, and the 10-meter bands. You could read all of them on your car radio. It also, in addition to being a converter, was a Q multiplier. This was powered by 3 AA cells. It simply went in series between the car radio and the antenna, and there was even a dial light for those motionless nights of mobile operation. $79.50 wasn't cheap, but there was nothing else like it on the market. And you can see from the center picture there the complexity of what all was inside this unit. In the 1958 Lafayette catalog, Regency also showed a companion 5-transistor broadcast receiver, model TCR2, that was designed for the ATC-1. It's interesting to note that during this time, the auto manufacturers were coming out with hybrid designs using a new line of space-charged tubes to eliminate the troublesome vibrator power supplies in car radios. The tubes were designed to run with 12 volts on the plate. This completely eliminated the vibrator and the power transformer. A further savings was realized by putting an audio output power transistor in the final stage. Some of you will remember those big fat Delco DS501s, anybody that worked on car radios back then. And these designs lasted from about 1957 to 1962. After that, the solid state world pretty much ruled car radios. Now, you know, this guy on the left had to show up. I guess he didn't have the scratch for the Regency, so he decided to run a 12AT7 as a space charge tube. Probably worked okay, but took a lot more AAA batteries to work. The filament alone was 150 mils at 12.6 volts. And the Regency was listed as requiring 450 to 600 microamps total at 4.5 volts. Things were getting a little more serious in February of 1967 with the ambitious experimenters. Here's a 50 kc sideband adapter for your amateur receiver that used a 50K CIF. I don't think there were a lot of them that did, but there were a few. There's also a frequency heterodyne meter. Special note on this, the author omitted an on-off switch because the two D cells at 12 cents a piece that powered this were projected to last 1.5 to 2 years. And the cost of the switch was 35 cents. Hams really were cheap even back then. Okay, April 1957 brings us to a RTTY tone standard that uses a transistor oscillator to excite the tuning forks used in RTTY alignments. All right, the next project here is a portable amplified direction finding loop. How else would you find a fox? Yes, they would hunt them on HF2. And again, we go back to basics here with a 2-transistor regen on July of 57. CBS is pushing power transistor line. Okay, Triad gets into the game with a list of miniature transformers specifically aimed at the transistor market. Other manufacturers are starting to bring in components as well. And the path to true miniaturization is beginning in earnest. The speech amplifier is a natural for the low frequency cheap transistors. Oh wait, the Q multiplier for the SX28. I'm getting ahead of myself here. Why not? Here was a homebrew one, and of course the Regency ATC1 had already done that, so you could add it to your SX28, and I'm sure some people probably did that. KW1, well, KWM1 rather, not quite your solid state rig, but notice the optional 12 volt DC power supply down here with a whole bunch of those, they weren't DS501s, but they were the same physical size as a DS501. 6 of them in there to provide the multivibrator for the mobile power supply on the KWM1. In August of 1957, W9AA Cy Reed wrote this thing for holocrafters, and I'll read this off unless you guys want to stop me. Transistors have been with us for quite a few years, but it is only recently that amateur equipment employing them has begun to appear. It would be difficult to name any other device of comparable value which has taken so long to become established in the amateur field. As a rule, the amateurs pioneer with every new gadget which comes along, but transistors have been largely left to government military applications and hearing aid people. There's good reason for this delay because transistors would not operate on amateur frequencies. Then too, their cost was prohibitive. Today, this situation is changing rapidly. It is now possible to purchase transistors effective up to 30 megacycles, which are moderately priced. This fall, we can expect to see a number of completely transistorized units, and they will be every bit as elaborate as any communications receiver on the market. And then right after that, Bill Halligan wrote, if in no other feature does a transistor excite interest, its power requirements should. Our SX100 receiver requires 85 watts to operate. A transistorized receiver of the same performance with a 5-watt audio output would require a total of 12 watts on audio peaks. He was right. Of course, we know that. Okay, we're all still seeing the small stuff, a 50 kc multivibrator for frequency standards, and 100 kcs were also pretty popular too. And there's a little code practice oscillator down here in the bottom. Can't make one. Where's the code practice? Now I messed it up again. Okay, transistor power supplies. We'll go with that. The power transistor mobile power supplies are starting to replace the old vibrators. They are quieter and don't fail as often. I made a lot of money in my high school days replacing vibrators in tube-type car radios. The repair shops in my small town didn't want to deal with removing and reinstalling car radios for repairs, but I would always do that because I was small and I could properly contort myself to remove and install them from the dashboards. There's a simplified code practice oscillator, and I don't know how you can make it any simpler than that. For the more adventurous experimenters, here's a complete sideband exciter with a single tube for the output linear amplifier. These are still not commercial units, but one-offs that are a labor of dedicated amateurs. I'll diverge a bit here and show some of the transistor progress in ARRL's handbook. In 1954, there was 2/3 of a page giving some basic information on transistors. This was the first time they really talked about it in the publication. In 1956, there were 5 pages of very basic circuits. In the rear of the handbook in 61, on the top right there, that was the listing for transistors, just one. And they then went down and got almost a full page. And then as time went on here, they got into a lot of transistors, and it was obvious that these were definitely catching on, and people were trying to do their best to utilize them. In the late 50s, these design products and build it yourself. Did I get it right? Yeah. To build it yourself articles to continue to concentrate on very simple 1 to 3 transistor applications. Then in 1959, an article shows how to build a 17 transistor 5-band receiver. From the looks of the circuit and its complexity, I doubt that few were ever built. And next we see a 65 milliwatt 6-meter transmitter. The author is using 2N247s in the RF section and points out the wide variation in transistor performance. Out of 12 2N247s, the final output ranged between 32 and 65 milliwatts. Shades of the old timers saving their best O1A triode for the detector circuits. In September 1959, this column from Bill Halligan gave a hint of things to come. There were rumors of a new solid-state rig becoming available, but it looks like it will be delayed. The FPM 200 didn't debut until January of 1961. It appears that there were about 50 that were made, but the real production had yet to begin. Later in 60 through 61, there was supposed to be a full production line run of 200, but it seems that the demand may not have justified that number being produced. This was the first HF radio to use all solid state, except for the driver and the final amplifier tubes. Currently on the internet, there is a registry showing only 3,200 sets. Perhaps the $2,660 price was a factor. A VW Beetle was about $1,400 then. This is what the FPM 200 looked like. Boy, I'd sure like to get one of those for display in a museum. I don't believe I've ever seen one. So we get down to February of 1960, and here's a 9-transistor 10-meter handy-talkie. And it's based on the new Philco surface barrier transistors. The author writes that only 3 out of a dozen SB100 devices would perform satisfactorily at 28 megacycles. Consistency in manufacturing is still a problem. Further on is a description of a 5-transistor HT for 2 meters. It's a 3-stage transmitter with a diode detector and 2 stages of audio for the receiver. Claimed range was about 5 blocks. Advertising for mobile power supplies continues to expand, and in the April 1960 QST, there's an article on the design of the soon-to-be ubiquitous items, because they were sure better than vibrators would ever be. In May of 1960, International Crystal released a group of 6 modular kits, including converters, mixers, audio amplifiers, transmitters, oscillators, and power audio oscillators. This 2-page ad also included a 15-transistor receiver for 27 microcycles CB at only $249.50. This included a NiCad battery, charger, whip, antenna, carrying strap, mobile mount bracket, and 2 sets of crystals. The transmitter power output is not mentioned. A 115-volt model was only $199.50. Next, we see a 12-volt, 50-watt modulator project that would be ideal for mobile applications. The complete project cost was $31. I'm sure the mobile operators took notice of this. Power consumption had to be much less than tubes. Here's a build-it-yourself article. Never being one to stand still, Heathkit announced the Mohican in June of 1960 for $110. This was an all-transistor general coverage receiver for 0.55 to 30 megacycles. It included an S meter, a BFO, and band spread for the 80 through 10 meter ham bands. It ran on 8 C cells or the optional 110 volt power supply. This is a very collectible radio today. We've had several at the museum, and we've sold 2 of them and got pretty good money for them. We were surprised at how much the collectors really wanted to pay. It's interesting to note that for a long time, the receiver manufacturers listed the 100 KC calibrator as an option. Very few sets had them built in. The marketing guys today do the same thing with the extra cost TCXOs. This is a 2-part article on the Ultimatic solid-state keyer. And the CW guys apparently really like these. In December of 1960, this 6-meter converter is using the Philco surface barrier line of transistors that were developed for television tuners. 6 meters fell just under channel 2 in the old NTS system, and 2 meters is between channels 6 and 7. And channel 13 ended at 216. I'm surprised we didn't see anything for the 220 megacycle band. However, I think it was underutilized at the time, and there was quite a lot of talk of reallocation away from the amateurs and so on. Fortunately, we ended up with at least some of it. In May of 1962, the 2-meter converter was done by the same guy who did the previous 6-meter one. The next item is a complete Hallecrafter's H04 transistorized electronic keyer. And the number and wide variety of types of transistors is really beginning to fuel the imagination of experimenters. Prices are also dropping, making them more attractive. The Autronic keyer by Electrophysics Corporation was tested by QST in October. This had everything you needed in one small box, utilizing 10 transistors and 10 diodes. It used flip-flops for dot and dash generation and included an adjustable side tone amplifier with a built-in speaker. Speeds were adjustable from 8 to 65 words a minute, and that sold for $70. In January 1962, 73 magazine had a full-page ad for the Davco, or Daveco, DR30 receiver. This sold for $389.50 and covered 80 through 6 meters. It had an FTT front end, Collins mechanical filter for sideband, a crystal filter for CW, and used ceramic filters in the 455K CIF. This was ruggedly constructed and very compact. It was packaged in a 4-inch high, 7-inch wide, 6-inch deep case. I've seen one at the ARRL Museum in Newington, Connecticut. It's a pretty rare machine. We also have a nice 2-meter transistor preamp, again using the Philco TV tuner transistors. The author stressing that these can be constructed without breaking the bank and with very acceptable results. Apparently, the variation among the individual transistors is getting to be less of a problem, especially at these high frequencies. September 1962 shows us that power RF transistors are coming along. Here's a 75-meter AM transmitter that puts out 80 watts. This is a respectable achievement again with lower price transistors. There's even a handy list of the currently available transistors in the article. In December 1962, the game changes appreciably. Sideband Engineering announces the SBE-33. This is the new company that was started by Faust Gonzat. He had retired from Gonzat several years prior and decided to come back into amateur radio manufacturing. The SBE-33 was a 4-band transceiver utilizing all solid state except for transmit driver and transmit finals. It covered 80, 40, 20, and 15 meters and claimed a power output of 70 watts PEP on all bands except 15 meters was 50 watts. All this in a self-contained unit with a 115 volt power supply, and it sold for $389.50. This was the first affordable radio that would lead to many copies of the basic pattern of 3 tubes and the rest being solid state. The high power transistors were just too finicky and expensive to replace these 3 items economically. Also notice that 10 meters is absent, probably due to transistor performance at 28 megacycles. At about this time, A look at the Allied radio catalog for 1963 reveals two completely solid state CB transceivers, the Vocaline Comair PT27 and the Cadre 510. Both of these have 5-watt transmitters. Keep in mind, this is DC input to the final. Power out was probably 2 watts or less. And there's a couple of 100 milliwatt walkie-talkies and an EF Johnson 1-watt walkie-talkie. And all of these are for the Citizens Band that was opened up in 1958. The number of manufacturers interested in this new market is increasing daily. And a note I have to add here is was not in my original display, but on the lower right of this catalog page, you'll see a Hammerlin HQ105 TR. One of those showed up at the museum last year as a donation, and we went, what the heck is this? Well, it turns out it's an HQ100 receiver. But what Hammerlin did is they added inside of it a CB transmitter and a crystal slot. So you could use this as a CB transmitter, and you'll notice the tuning knob on the lower right-hand corner seems to have a chrome ring around it. That chrome ring is actually calibrated for the 23 channels. Now, the little gizzy on top there, that's the sweetheart. That is an 8-crystal switch with a cord that runs down and plugs into the circuit chassis in the back. So now you can have 8 channels at your fingertips and your CB radio with 5 watts output. When we first looked this up, the price on this thing was a little over $300, if I'm not mistaken. And now you look down here and it's only $219. And then they charge you a little more if you want the switch. The switch wasn't too much. Oh, down here at the bottom, $16 for the switch. And the switch had a very clever design to it. It had these special clips that clipped into the bottom of it, and they were sort of spring-loaded, and they went into the little air holes all punched into the receiver before it was a CB receiver. So you could mount that switch box up there, and when you were done and you want to take it off, you still had a perfect cabinet on your receiver. And you didn't need the switch anymore because obviously you got your ham license and now you need a real transmitter. Anyway, that was an interesting note that got stuck in here. Okay, I'm boring you, I can tell that. Well, I don't hear any snoring. It must be okay. All right, in August of 1963, Gonza introduced a Sidewinder. This was a completely solid state 2-meter transceiver that put out 20 watts PEP sideband, 6 watts AM, and 20 watts CW. Not exactly high power, but definitely pointing the way. The advertised price was $350, and the power supply was another $40. Notice the lack of FM at that time. The right side also shows, oh, wait a minute. Justin Incorporated came out with the Mobile Trans 40. Let me silence this thing. There we go. It's a single bander for $100. Came out in August of '64, and it was available for $40, $75, or $160. It contained a receiving converter for your car radio and a 40-watt transmitter with 3 front panel selectable crystal sockets. The circuit had 9 transistors, 6 diodes, and 1 tube. The emission is described as modulated carrier amplitude control by voice. The heck is that? Well, that's what I said. It turns out what they did, they took the audio amp, and as the audio comes up, they fed it into the modulator, but they also used it to generate DC for the output. And it was the speed, as long as you were speaking, you were getting high voltage. And as soon as you shut up, there was no high voltage. I've never seen anything like that before, and I have no idea if I'll ever see anything like that again. But that's what they were doing. Hey, whatever works, I guess. And the right side of here shows the diagram of it. So stranger things have happened, I guess, here and there. Now you'll see solid state frequency converters. This is Vanguard Labs. These guys built all kinds of stuff. And this is a very nice listing of all the different circuits and whatnot that they put together and went on to offer to the hams. There's literally almost anything you could want in there for toys to play with, all transistorized and so on. They advertised a telephone handset portable radio for $59.98. They offered transistor converters for both ham receivers and standard broadcast radios, and the coverage included CB 6 meters, 2 meters, 5 megacycle WWV, CHU, Marine, aircraft, and police, fire, public service bands. And there was also a budget slow scan TV. And then in December of 1964, Gonza announced the new SBE 34, a substantial improvement on the 33, and the price is listed at $395. The Lafayette radio catalog for 1966 listed the HA640 portable 6-meter transceiver for $120. This was actually available on 10165. It is a 2.5 watt input with a reported efficiency of greater than 50% and provision for 6 crystals in the transmitter. The receiver was a tunable super het, and it only took 10 D cells to operate. Regular D cells were 13 cents a piece, and our rechargeable NiCads were 49 cents a piece, and you could get the 110 volt power supply for $17. Now here's a nice listing of low price transistors for amateur use of October 1966. There are only 3 power transistors that will do more than a watt at amateur frequencies. 2 at 5 watts and 1 at 4 watts. The high power ones are for audio and power supply chopper applications. Doesn't look like the all solid state 100 watt rig is ready for prime time quite yet. However, the author of the article notes that there are currently over 3,000 transistor types on the market. 1966, that's 18 years after the transistor, 3,000 types. In August of 1967, Amico shows up with an all-solid-state receiver with continuous coverage from 0.54 to 54 megacycles. It includes a BFO and an uncalibrated band spread. All this for only $79.95. I have a little side note here too. At this point in 1967, even though Congress had set up a framework for use of the metric system in the 19th century, the U.S. continues to use U.S. customary units based on English measure passed by Parliament under the reign of Queen Anne in 1706. Even though Congress, on February 10th, 1964, the National Bureau of Standards, now National Institute of Standards and Technology, issued a statement that it was to use SI except where this would have an obvious detrimental effect. In '68, Congress authorized the U.S. metric study the emphasis of which was to examine the feasibility of adopting SI. The first volume was delivered in 1970. The study recommended that the U.S. adopt the International System of Units, and in 75, Congress passed the Metric Conversion Act of 1975, which established a national policy of coordinating and planning for increased use of the metric measurement system in the United States. Metrication was voluntary and to be coordinated by the United States Metric Board. So we do finally now at this point have the metric system much more widely in acceptance in this country. I thought that was an interesting thing that fit in with the history here. In 1968, February, was the debut of the Drake SC2 and SC6 receiving converters for 2 and 6 meters. These were all solid-state FET transistor circuits. These were accompanied by a handsome CC1 case and power supply to match the rest of the Drake R4 T4 line. And by this time, Drake was already incorporating a few transistors into its designs, starting with the permeability tuned oscillator and the VFO. March 1968 is when Realistic brought out the DX150. This was a fully featured receiver with a product detector, VFO, calibrated band spread, selectable AGC time constants, antenna trimmer, and a receive standby switch. It could be operated from 12 volts or 115 volts AC. It listed for $130. This was imported from Japan and was indicative of the possibilities that lay ahead in solid-state receiver design. Unfortunately, the RF power transistors were still relegated to the CB enthusiasts with their 5-watt units. The Allied catalog has several pages of CB transceivers that are all solid state with any and all options you could want. Hammerland debuted the HQ215 receiver. This appears to be their answer to the Collins S line. Full hand band coverage and provisions for 13 extra band crystals. April 68 brings the announcement of the R530 by Galaxy Electronics. All solid state and high performance with crystal lattice filters and a noise blanker, suggested price in the $700 range. That's still a pretty pricey receiver to me. QRP is alive and well. And in December 1968, this milligallon transmitter, that'd be a watt for those unfamiliar with a gallon, for 15 meters, uses 2 plastic case transistors that retail for 64 cents a piece. Hams still live cheap. By 1968, there's an article on the first IC developed with the ham in mind. The National Semiconductor LM270 has circuits for squelch, vox, and speech compression. An in-depth discussion of its use follows. Allied Radio jumps in with the all-solid-state A2515 in February of '69. The description includes 4 mechanical filters. I wonder what they were using for filters at the price of $90. I suspect ceramic resonators instead of IF cams. This is an imported radio. In October '69, Drake announces the SPR4. This covers 150 to 500 kc and 23 segments of 500 kc each over the range of 500 kc to 30 megahertz. Crystals are supplied for long wave standard broadcasts and 7-form broadcast bands. This appears to be an SWL's dream machine for $379. There were also several crystal set options for WWV, Marine, CB, etc. In November 69, QST opens a 9-part series on transistor theory that was reprinted from Telephone Engineering and Management magazine. This is a very in-depth look at theory and applications from the engineer's view. January of 1970 brings the Ten-Tec PowerMite PM1, an 80 to 40 meter transmitter with an expansion available to include 15. This rig sold for $50 and proves to be a very popular rig for the QRP crowd. January also shows the Lafayette HA800 amateur receiver, which covered 80 to 6 meters and included double conversion and a product detector for only $150. And March 1970 brings a pair of monitor receivers for the commercial bands at 152 to 174 megahertz from Lafayette and Allied Radio. The two are viewed in QST, and it appears they are made by the same company in Japan. There are only minor differences between them, and are about the same size as an ordinary 6-transistor handheld radio of the time. Sold for $18. And now the old guys all look at this page and go, yeah, polypacks, holy cows. We all had to look over there and look at all the goodies we could buy at, like it says, ridiculously low prices. But the high power and RF transistors still aren't quite making it. There's a glimmer of hope with the 23 watt. Which one is that? It might be this one. Yeah, 400 megahertz. Yeah, that's it. For $2.99. 23 watts is not too shabby for transistors, especially ones that sell for $2.99. And of course, ICs are starting to show up all over the place. And the possibilities of circuits containing hundreds of transistors is fast becoming a reality. By 1970, in December, Henry Radio became the importer to distribute the Kenwood HF twins. The R599 was all solid state, and the T599 had 3 tubes, a driver and 2 finals. This was the beginning of the real Japanese invasion. January of 71 showed Yaesu not far behind with their FT101. This was a one-piece transceiver with both 12 and 110 volt power built in. It was a good radio that went through several iterations in its long life, culminating in the FT101ZD. This last model came with 6146s in the finals instead of sweep tubes. And our friends from Regency are still in the game here. This all-solid-state 2-meter FM rig was capable of both simplex and duplex operation. Remember the TR1 transistor radio and the ATC1 amateur band converter. 1971 also sees a flood of advertising for all solid-state radios. Most of these are low-powered transmitters for 2-meter FM. Veritronics is introducing a line of products from Inouye, later known as Icom, and Harrison Radio has a line of SCC products. National joins the HF fray with the NC1000, which has the 3-tube design like its rivals Kenwood and Yaesu. Unfortunately, like most of the tube equipment manufacturers in the US, solid state is found to be a difficult transition. Ten-Tec announced the RX-10 in February, a 4-band ham transceiver for 80 to 15. To encourage new hams, it even has a built-in code practice oscillator. In 71, QST decides to take an in-depth look at 2 of the E.F. Johnson FleetCom units. One is a handheld and one is a mobile unit. Although design For the commercial band of 150 to 174, they wanted to check the performance against the amateur units currently available. These units cost 2 to 3 times as much as ham gear, but the conclusion is they're worth it in performance. These are probably an indication of what will come to the amateur market as prices fall on semiconductors. Henry Radio's showing a line of 2-meter transceivers and a power amplifier. There's also a portable battery set available. Can the handhelds be very far behind? October 71 sees the introduction of the Drake DSR-1 receiver with continuous coverage from 10 kc to 30 megahertz. This includes a frequency synthesizer and a digital frequency display with a claimed frequency readout accuracy of 100 hertz. All this for $2,195. We also see Ten-Tech's Argonaut advertised with 80 through 10 meter coverage and 5 watts input to the final. This is a sideband and CW rig. There's a note that this will be available soon. Stay tuned. There's an article on transistor RF power amplifiers in the March 72 issue. There we go. There's a 1 transistor power amp capable of 160 watts out with 4 watts of drive. The unit cost of the transistor isn't mentioned. In September 72, a multi-part article on solid-state amplifier design debuted. In the intro, they listed 3 advantages of using transistors. Probable lifespan, 100,000 hours. Wideband amplifiers are easily constructive. Octave and even decade bandwidths are possible. The small size of a solid-state PA is attractive for portable and mobile designs, and in the same article, they listed prices on some of the transistors that were available. Later in Swan introduced the SS100, all solid-state transceiver. It first appeared as a text-only ad in December 72. The full picture ad appeared in March of 73. It appears this is the first reasonably priced, generally available solid-state rig. Later in September 73, there's another article on solid-state wideband amplifiers for HF. This appears to have a design that will be used for several years to come. Skipping ahead to February of 74, we see the Ten-Tech Triton in May, the Atlas 180. Atlas is designed and built by a former Swan employee. Both are all solid state, as the rest are shown in the last 2 slides. Whoop. Signal 1 comes along in June of 1974 with a very expensive top-of-the-line rig which included a digital display. For an interesting story, which I don't have time to go into now and I don't want to bore you with, but you might want to look up on the internet and look for the history on signal radios. It's a pretty scary story. A lot of people spend a lot of money. Swan has also announced the perfect mobile rig, a 160 watt PEP monobander for 80 or 40 meters. The SB104 comes out in December of 1974. Heathkit couldn't wait to get this thing on the market, complete with separate station monitors, remote VFO, power supply, speaker, linear amplifier, a truly integrated HF station in the style of the tube equipment manufacturers. Collins and Drake, etc., always like to show a whole desktop full of all the little individual pieces. But after this flood of equipment came to market, the transistor was finally bidding to rule the radio amateur market. Interesting note, the SB 104 was actually recalled by Heathkit. One of only, I believe, 2 Heathkits that were ever recalled. I think the other one was one of the early 2-meter rigs. So that pretty much wraps it up. I hope some of you have at least enjoyed this little trip through history.